Hello, this is Mr. Huber. In this lesson, we're going to look at modeling quadratic functions. So there are instances where we've got some data, maybe just some points on a graph, and we want to find out an equation that goes through those points. We've done that with lines before. You can do linear equations and lines of best fit. So we're going to see how we can find quadratic equations that best fit some data and some points on a graph. We follow the same calculator instructions we did for linear equations to model with quadratic equations. We're going to have to enter our x and y values into the calculator and then have it do the work coming up with the equation for us. Instead of picking a linear regression, as it says right here, we're going to pick a quadratic regression. So linear regression, that's what we did before. Now we're going to want to do a quadratic regression. So when we do that, we're going to look for this option on the calculator, and that'll be under the calculate stat menu. We'll get to that here when we do an example. First example gives us some points on a graph. So we've got 0, 0, -1, -2, and 1, 6. And we want to find an equation that will go through those points. Okay? For this instance, we're going to want to enter this information by pressing the stat button on the calculator. Okay, this is the same as we would when you're doing a linear line of fit. So we press stat and then edit, and you can find those instructions back from when we did it before. You have those sheets and you can use them. We're going to enter under L1. So on your calculator screen, when you hit stat and then go to edit, you're going to see L1 at the top, and L2 and L3 and such. Under L1, you're going to enter your x values. Okay? These are your x values. So you're going to put a 0, -1, and 1. And in L2, these are your y values. You're going to have 0, -2, and 6. After you have that data entered, you're going to press the stat button again. And this is just to the left of the arrow buttons on your calculator. It says stat. And now you're going to arrow over to the right instead of edit to calc, C-A-L-C for calculate. And this is where you'll see that option 5, where it says quad REG for quadratic regression line of best fit. So you're going to go to option 5, and you're going to make sure that the X list is L1, Y list is L2, which is what we just talked about. And then you go down to calculate, and you're going to get on your calculator screen, you're going to have an A value of 2, a B value of 4, and a C value of 0. Now we can use this to write our y equals ax squared plus bx plus c equation. So in this case, we're going to have y equals 2x squared plus 4x plus 0. We wouldn't even have to write that plus 0. This would be our equation here. Y equals 2x squared plus 4x. That would be the equation, okay, see right here, that's the equation of the parabola that would go through these points. Again, standard form. Standard form is ax squared plus bx plus c. So we've just written an equation in standard form for the parabola that goes through these points. Enter them in your list 1 and list 2, and then have the calculator calculate that equation for the quadratic function in standard form that goes through those points. And you want to practice that, make sure you know how to enter the information and calculate those. If it's not coming out properly, then seek the assistance to make sure you know how to use it, because the calculator doing this is a wonderful tool. Let's do a little trivia here for the national pastime. Major League Baseball. It's difficult these days for pitchers to win 20 games in a season. Who was the last Major League pitcher to win 30 games in a single season? The last player to do that actually pitched for the Detroit Tigers. Danny McClain in 1968. The Tigers won the World Series that year, and he went 31-6. The last time, it's been a while, since a pitcher won 30 games in a single season. Let's see here an example where we can use a quadratic function to model some real-world situation data. And we've got a table of values here. This is going to be like an x and a y. We're going to have to enter these like our x's and our y's. So we've got some predicted temperatures for different times during the day. And what you're going to want to be able to do here is recognize how to enter these x values. Again, right? These are our x values. These are our y values. So we're going to enter a 6, 9, 12. Then for 3 o'clock, we're going to have to enter a 15. for 6 o'clock and 18. These are the number of hours since midnight, if you will. Like 6 a.m. is 6 hours into the day. 3 p.m. is 15 hours into the day, and so on. And so those are our x values. The y values will enter just like you see there. So you're going to want to go into the calculator under Stat and Edit, and you're going to want to put these values in for your x values and for your y values. You're going to have to clear out the values that are in there for list 1 and list 2. Again, press the Stat button, then under Edit. Under L1, you're going to enter 6, 9, 12, 15, 18, and 21. And then in your y values, for L2, enter 63, and so on down those y values. 76, 86, 89, 85, and 76. Double check, make sure your values are entered correctly. If the values aren't entered correctly in the calculator, then things aren't just going to magically work out. So make sure you've got the data entered the way you want it. And now you're going to go back to Stat and Calculate, just like you did before. And you're going to want to go to the quadratic regression, again, option 5. And then when you calculate, it's going to give an A value of a big long decimal. That's okay. So our A value is negative 0.329365, and it keeps going. We'll just enter that for now. Our B value would be 9.7976, and it keeps going. And our C value, 15.5714, and it keeps going. We'll enter these to a couple decimal places. All right. Typically, we'd be given a place value on a round answers to. Here, go a couple decimal places with each of these. So I'm going to move this up slightly so we can write maybe underneath here. And we're going to get an equation of y equals, let's go back to our pen for that one so we can fit it in a little easier. All right. We're going to have y equals negative 0.329x squared plus 9.798x plus 15.571. That would be our equation. You'll notice here we want to use the equation to make a prediction. Set in the directions, we go back here. We want to write the quadratic model and then use the equation to predict the high temperature for that day. So we want to use this equation to predict the high temperature. It might be hard to use the equation to predict it, but we could use the graph. You can calculate a minimum or a maximum on your graph. So if we go to our graph, we're going to have a parabola graph. You may have to adjust your window, right, so that you can see the parabola on there. So then once you get your window set, and here for your x values, our x values are going from 0 past 20. So your x minimum should be 0. Your x maximum, let's say 24. And your y minimum, if you're only looking up to 10 on your y values, you're not going to see any of these y values. Look, all of these y values here, the lowest one is 63. So your y minimum you might want to have at 60. And then your y maximum goes up to 89. So at least past that, we go to 90 at least. And now if you press graph, you'll be able to see the parabola, the data that's there, and you may have to enter this equation in your y equals. You're going to see just some points right now. So go to your y equals and enter this equation that we just had here. Okay? So in your y equals, make sure there's nothing else under y equals, you're going to enter negative 0.329x squared. Then you're going to do plus, right, 9.798x, and then plus 15.571. Again, make sure you've got it entered correctly. You've got an x squared, you've got the x, you've got everything in there. And now if you press graph again, you're going to see a line get drawn that's pretty much going through your points, right? It should follow the points that you've plotted here, right? These points that you plotted, there's a parabola that goes basically through those points. And now we can calculate about where that maximum is. To do this, a little different place on your calculator. Just below the calculator screen to the right side, there's a button that says Trace. Don't push Trace. We want to go to Calculate, which is right above it. So press second and then the Trace button. And under Calculate, you're going to see options of value, 0, minimum, maximum. Option 4 says we can calculate a maximum. So you're going to go to option 4 to calculate a maximum. And then it's going to ask you on your screen to pick a left boundary. You want to pick any point to the left of the high point of this graph. It doesn't matter where. As long as you're to the left of that vertex, you're okay. You press enter. Then it's going to ask for a right boundary. So you arrow over to the right until your little cursor goes to the right of the vertex and press enter. It's going to ask for a guess. You don't need to guess. Okay, generally, your calculator screen should look like this. Okay, a quick sketch of it. You're going to have a parabola like this. Okay, you're going to enter a left boundary and a right boundary so that you can figure out what this point is right here. Okay, so when you enter the left boundary, it's going to have kind of a line up and down and a line up and down at the right boundary. You want a left boundary and right boundary on either side of that vertex, where then you can press enter for your guess. You don't have to guess. And it should take you to a maximum. The maximum in this case is an x and a y value, right? Our x value for the maximum is 14.89, and it keeps going, and our y value is 88.52. So this is the high temperature, right? The y value, temperature. So the high temperature for that day, it asks us in our question here, predict the high temperature for that day. The prediction for the high temperature that day would be 88.5 degrees. Okay. Then it asks for what time the high temperature occurs. What time? So it occurred at 14.89 hours after midnight. So almost 15 hours. So close to 3 o'clock. A little bit less than 3 o'clock. So maybe like 2:50. Okay. So you predict that the high temperature would occur sometime around 2:50. Make that a little more clear there. Somewhere around 2:50 p.m. that day. Again, we can use the calculator to get the graph drawn, to find those maximums and minimums when it might not be as easy to do by hand. So get comfortable using the calculator, entering lists of data, okay, getting the equation, right? So getting the equation for the linear regression, the quadratic equation, not the linear regression. Similar steps, but we just go to quadratic regression instead of linear. And then we can use the graph to make some predictions and to find data like the high point and low point. Minimums and maximums we've seen are important pieces of these parabolas. So we can do all of that using the calculator, get comfortable with the steps, make sure you're getting the practice in entering, using the data, getting the equations and the graphs, and then you can have the heavy lifting done for you by the calculator. You need to make sure you understand what's going on so you know how to use it properly.